Let's talk about Jupyter. I work in the data industry, and I don't have a traditional background either. I mentioned it at the beginning that I'm an aerospace engineer. Therefore, I don't have formal education in software engineering and so on. For me, Jupyter was amazing, and it helped me learn a lot how to code and communicate my results, and in general, become a programmer, right? But it has kind of a bad reputation these days because some people have had to translate code that was on a Jupyter notebook and then put it into production, for example, and that translation process might be a little bit difficult depending on the original notebook. And also Jupyter as an ecosystem has been changing a lot, evolving like versions and sometimes breaking backwards compatibility with extensions and so on. So, as any other project, it has pros and cons, and it's in constant evolution as well. In my opinion, I think Jupyter can be made an excellent tool for coding and compensate some of its drawbacks. However, that is not the default installation experience, and one has to go a little bit further and install some extra extensions, plugins, and so on to make the experience a little bit more enjoyable. So here's a few recommendations. First of all, make sure that you're on the latest version. I'm going to show today the new Jupyter Notebook, which is based on the new Jupyter Lab. This was released mere months ago, maybe 3 months ago or less. And also because this gives you interactive debugger that was there in previous versions, but now it's much more polished, a variable explorer, and many more things. And also, I highly recommend you to install a couple of extra packages. One of them is this pair here, Jupyter Lab LSP and Python LSP server. These packages enable support for something called the language server protocol, which is a fancy way of describing a standard so that editors, IDEs, and so on can extract information from the code itself. Things like linting, formatting, detecting mistakes, unused variables, and so on. It's nowadays based in many cases on this language server protocol. And adding these extensions to Jupyter make it much more powerful and interesting because it gives you some extra debugging capabilities. We're going to see some of those. And then a package that I discovered quite recently, actually, although it has been going for some years, as far as I know, is ipyflow. So ipyflow provides a so-called reactive kernel. And this reactive thing means that it can detect when one cell depends on the other, for example, or when you change one cell, it can tell you to run other cells that depend on it. And we're going to, again, see some examples of this in a second. And I think this is a massive life changer when it comes to using Jupyter, because you avoid things like out of order cells and silly errors because you're reusing a variable and things like that. So let me go to Jupyter and see how this looks like in practice. So I'm going to open this ipyflow notebook that I have. And I'm taking this example from a very famous talk by Joel Grus called I Don't Like Notebooks. This happened during JupyterCon 2018, and it has become a classic because Joel is a super engaging and funny presenter, and he walks through some of the problems that Jupyter Notebooks had in his opinion. So even if you do love notebooks, it's a really good talk to see. Some of these problems have been addressed in the past 5 years, but some others still stand. So I'm taking this example from his talk. This is one of the first slides in which he describes this super simple code that when run from a terminal or a interactive terminal like IPython, you have a very clear view of what's the order of the execution, and you don't expect any surprises. But what happens if we put this on Jupyter? So let me reproduce that code here. So we have our function x that returns x plus 2. And I think you're already seeing the automatic completion that I have on Jupyter, right? So the moment I'm writing code, it already offers me lots of hints. And in fact, it also highlights some of the linting issues that might happen here. I see that this is cell number 8, so allow me to restart the kernel here for a second. There we go. And in principle, if I assign y equals, calling the function f with the value 2, then we know that I will be equal to 4. And if I print y, then this is 4, right? So far, nothing fancy, but in his talk, Joel was showcasing what happens if you reorder these cells or try to trick the user. So for example, let's say that I change this code here sneakily, and then I execute this and that. So if I don't show you anything, then you see that, wait, hold on, because I'm going to edit this back again. You could be tricked into thinking that the code is utterly broken, right? Because the function f is returning x plus 2. So 2 plus 2 should be 4. But then e equals to 4 gives false, and print y gives 4, right? So none of this makes any sense. But the thing here is that I've been like executing the cells in a different order, and I've been modifying the cells and so on. In modern versions of Jupyter, you see this orange marker here on the text when you have modified a cell, but you haven't executed it, right? So this is already a very good hint that didn't exist in 2018. But what happens with the rest? So let's say that I execute this function. Now you see something that I was not explaining before, which are these markers on the left. And these are essentially telling me that now I need to execute all of these cells because the function definition has changed, and therefore I need to evaluate all the rest. So now I can do this, this, and that. Now everything is ready. As you can see here, there's also these little dots that point to the fact that this cell that is printing the variable y depends on cell 9, right? Because that is the one that assigns the variable. It also depends on cell 8, because that's the one that defines the function. But there's no little dot here, which means that this cell does not really depend on that other cell. So if I change this for whatever reason, and I execute it again, it's not going to signal that I need to somehow execute the function again. And you can have even more complex examples. These are taken from the documentation. So I'm going to break my exception of creating meaningful variable names. And if you have x and then x plus 2, you see these two cells depend on one another. And if I change one, then I need to execute the other. Then I can have this y that is x plus 3, for example, and then I print y. So essentially, when I modify x, I will need to rerun this cell over here and also this one, because y depends on x, right? And that's exactly what's happening here. So I have two green markers here, which tell me that I need to execute these cells so that the results get updated. So I have this, and now I have this again. So long story short, this was all powered by ipyflow. In fact, you can see here on the top right this little logo here. And I find this super useful when working with Jupyter in general. It even has a mode that automatically executes everything that has to be changed. But well, that can be a little bit annoying sometimes. Maybe if you have like some cell that has a long computation and so on. And even with this mode that only tells you with color ribbons what cells do you have to execute again, I find it super useful. If you want to use that, you need to pip install ipyflow, and then when selecting the kernel, you have the ipy kernel, which is the default one that usually comes installed with Jupyter, and then you can change it to ipyflow. In fact, if I change the kernel now, you see that all this information on the left disappears, right? Then I switch back to ipyflow, and now I have this information again. So any questions about this part? Yeah, that video has lots of views. It's a really famous talk, and I think it's uploaded to different places. Okay, so let's talk about a couple of other things. So I'm going to now close this notebook. All of this is going to be uploaded to the repository, by the way. So if you want to have a look at the material already, you have it there. Now, the second part, I want to briefly show the Jupyter debugger, for which I'm going to open this notebook here. And this notebook contains some data science code from another talk of mine about how to use polars and Kedro to perform data science tasks. And you don't need to understand everything that's happening here. Hold on. There we go. But essentially, this is using the polars library, which is a modern data frame library that learned some lessons from pandas and made things their own way so that it's super fast and super nice to use. And it's doing some analysis here with some of the statistics of the dataset and so on. I don't want to spend too much time on that. What I want to do, though, is showcasing a little bit a couple of ways in which you can use the debuggers on Jupyter. So one of such ways, the most primitive one, is by using something called setTrace. So setTrace is the original debugging mechanism in Python. It's really simple and primitive, but it's sometimes really helpful when debugging in conditions in which you don't have a nice IDE and so on. So let's scroll to this part over here. There we go, in which I'm creating a modified version of the data frame after doing some operations here. And I'm going to turn this into a function. So I'm going to call this cleanup barriers, and it's going to receive a data frame. And then this is going to do a few things. So I'm going to store this expression here, polars.call, blah, blah, blah. And then I'm going to use that expression there. So this is going to be new data frame, and I'm going to return the new data frame here. And then I'm going to say that df is cleanup barriers of df, and then do this. Okay, so I didn't change anything. what I did was turn the code that was already there into a function. And the purpose of that is to do a line-by-line debugging now. So let's say that something is not working as expected, and I want to understand a little bit why that's happening. So for that, I can do here import pdb. This is kind of non-standard because usually we don't import modules inside functions, but for pdb, people usually make an exception. And then we can do pdb.setTrace. And when we do that, and we execute the code, you see that on the Jupyter interface, everything is kind of frozen. So on the top right, you see that there's this icon here that says that the kernel is busy and has been busy for already 15 seconds. And here, there's this ipdb prompt that is waiting for me to introduce some input. And this is a little bit cryptic, but the first thing you can do is to type help here. And this is going to list a number of commands that you can use here. So for example, if you do list, then this is going to showcase the lines of code that surround my current position. And then there's a number of operations that I can do. For example, I can execute the command step. And step is going to step into a function. You see, in the line 4 that I was debugging before, the first function that was appearing there was this pl.call that is going to represent a column of my data frame. And by doing step, I'm getting into the source code of that very function. So now I can see if I do list or L for short, and I repeat it, you see that it's displaying the doc string of the function, which is really long because it has lots of examples. And I can even do next. And this stands for go to the next line of code that is executable. So you see here now I'm already at the point in which I'm observing the execution of the code. So for example, I have no idea what this more names variable is. That belongs to the header of the function, most likely. So if I do print more names, and this one goes without parentheses, oh, sorry, it should be P. More names is an empty tuple, and there's another variable called name that has the name of the column and so on. When I'm tired of executing the function like this, I can write return. And then this is going to go exactly to the return point of this function. So now the moment I do next, or N for short, see, it goes back to the original place I was in. So now the pl.call function call is done, and I'm going for map dict in this case. So I can do the same. I can do S. This is going to get into pl call again because I'm calling it here. So I can do R, the next. Now I do S again. And this is going to show more outputs, please. And now this is going to get into the mapdict function, and so on and so forth, right? So I can go step by step. I can move inside the code, or I can get outside of a specific function that I don't want to know anything about, and so on. And the last thing I'm going to do is, if I do next, and then I display where exactly I am, hold on. No, I think it's easier if I do it here. So I'm going to do up. This moves me up in the stack, L for list. And I can set a breakup point at line 8. So line 8 is going to be that one there. And I do break 8. ipdb tells me that there's a breakup point right there. And now if I do continue, the code is going to do whatever it has to do, and is going to jump to my breakup point. So now I see, for example, that my expression is already a Polars expression object. and I see that my new df is still not defined. But if I do n for next, now new df is right there. So now I can do R from return, R again, continue, and the execution is done. Okay, so this is a really powerful tool to understand how a code is working line by line. However, it's a little bit arcane. Like I was doing it really fast because I know the commands by heart, right? But learning how to do all these things takes a little bit of time. It turns out there's a better way of doing this, more visual, which is by using the native debugger. So I'm going to comment this out. Right? And if I execute it again, you see that now it's executed instantly. I'm going to add now another function called breakpoints. And I'm going to turn on the Jupyter debugger here. So I'm going to click here. You see, it takes a little bit of time. It's doing some stuff. Now the debugger is on. I'm going to view right side of our debugger. And you can see here a number of things. So these are all my variables. So df, my categories data frame, and so on. And what I'm going to do is I'm going to set a breakpoint again in the same line as before. You see that it's marked with a red dot here. And if I run this code, you see that first of all, the code stops right next to the breakpoint. So it stops right here. And as you can see, there's this df variable. And there's a number of controls that I can use that are essentially equivalent to the commands that I was running before. So this is next, this is step in, step out, and so on. So at the moment, I'm going to do next, 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 next. And you see that there's a new expression appearing here that has a number of properties. So I could go and say, okay, what's the string representation of this expression, or the HTML representation of this expression, and so on. When I'm happy, I can click continue. And again, the cell is going to finish and just produce the result that it's supposed to produce. I can disable the debugger now, and everything goes back to normal. In fact, when you disable the debugger, the breakpoint function does nothing. So it's the same as not having it. Okay, I'm going to look for the Q&A again. Carlos said a few minutes ago, not related with this part, but what are the first 3 things you do when you can't reproduce an error? It's a really good question. So it depends on how much information do I have beforehand. So for example, let's say that the user was really well behaved and they gave me already what Python version they were using, the libraries they were using. Ideally, they give me a whole list of dependencies so I can exactly reproduce an environment. And I still cannot reproduce the error. So probably the first thing that I would ask is, how did you install these libraries? Because maybe that plays a role, right, in the misbehavior of the code. Maybe if they installed with Conda and I'm installing with pip, there might be minor differences that, for whatever reason, can amount to a difference in behavior. That would be the first thing, like, how did you install this thing? Then the second thing would be trying to understand if I have all the information I need about the environment. For example, are there any environment variables that can affect this result? Do you have any specific system library that maybe I don't know about? Is your hardware the same as my hardware? For example, I'm now giving this talk from a Mac M1, which has a different CPU architecture from the Intel Mac computers, right? So that would be the other thing, like understanding if I am really, really reproducing the same the exact same conditions as I was saying before. And the third thing would be, that's a good question. I don't know what the third thing would be. Probably, again, it depends on how accessible the other person is, because if this is a random issue on the issue tracker opened by a bystander, I cannot tell this person, yeah, let's have a video conference and see your computer, because that might be a lot. If it's a coworker, for example, I can go to their computer directly and see what's happening there. So whether or not I can afford to continue an asynchronous conversation, or if I can jump to synchronous, that's super important as well. I hope I answered the question. Ido says, where is the breakpoint coming from? Breakpoint is a built-in function. So if you do breakpoint and do like this, for example, this function breakpoints, you can do help breakpoints, and this is a built-in function. So it doesn't come from anywhere. It comes pre-installed with Python. So you have it in every installation you have. In fact, it's not specific to Jupyter. It can be used on a normal Python interpreter as well. Okay, and last but not least, I'm going to devote some minutes to another editor, which is VSCode.